1956, and what an eventful year I have for y'all this episode. By the end, we'll have a major milestone passed, and I guess I want to leave that a bit of a surprise for y'all. You'll see at the end of the episode. And of course, all things will start out small. We're going to begin the year with another flight of the Ohote 2. This is Flight F of the biological capsule, and the first of 3 launches of the Ohote 2 we have scheduled this year. All of these missions will be seeking to gather biological science in the upper atmosphere in the space above 140 kilometers in altitude. The keen-eared of all of you might have heard this, but unfortunately this first mission was a failure as the A4 engine powering the Ohote 2 lost thrust and its performance was diminished as a result. Ultimately, the payload would not reach the desired altitude, but flight data was recorded into the return capsule and would be recovered alongside the species being tested in this flight. Following that flight, around a month later, we have the launch of the Ohote 200. This is going to be Flight A. This year, we will be doing a lot of downrange experiments that don't directly contribute to science like our earlier suborbital rockets. Instead, the 100 series of Ohote boosters are engineering tests in the lead up to orbit. As for the Ohote 200, we have 2 flights scheduled for this year, and ASP administrators are hoping for at least 2 successful test flights. In each launch, we will be testing out code that will take us into orbit, as well as streamlining the manufacturing process of the hardware associated with the booster. And as you can see there, we have encountered some issues with the software as it activates the second AJ-10 engine instead of hot firing it at the next staging event. This led to a failure of the mission and the objectives that the administrators had set, and they would place their hopes on the next launch. Though this had achieved approximately 900 kilometers downrange. Some 11 days later, a new test pilot hired for her exceptional skill took to the sky. Her name is Gwendolyn Ross, and she was hired by the ASP team at the end of 1955. She spent much of the first 2 months of 1956 training for the plane that she would be operating in this launch, and in March, she would take to the sky for a live training exercise. Her task, however simple, would be to perform a short circuit to familiarize herself with the handling of her X-Jet test bed and learn the takeoff and landing procedures. Administrators were not disappointed as she made a perfect run, landing some 15 minutes after takeoff. On March 24th, the Ohote 3F Flight D would take to the sky, turning approximately 5 degrees west of due north in order to photograph the eastern coast of Florida. purpose of this mission is largely civilian. It is to gain data about beach erosion and compare this data to logs from the past few years. This would largely be a demonstration of the scientific and environmental purposes that upper atmosphere or low space photography could serve in the program. Of course, the mission would perform perfectly, and this success would allow for two more Ahote 3F flights to be commissioned in 1956, demonstrating that planetary photography can be used for peaceful and scientific endeavors as well as military ones. Following the failure of the previous Ahote 200, Flight B would roll out onto the launch pad on May 1st at approximately 3 in the afternoon. The main difference between the 200 and its 100 counterpart is the replacement of the NA-75-110 with the XLR-43 NA-3 engine. This had a greater thrust and a more efficient burn, utilizing ethanol 90 compared to the ethanol 75 before. This change allows much higher combustion chamber temperatures and a greater percent of fuel burnout. Following the completion of the first stage burn, stage 2 ignites, and a similar error to our first flight is encountered. At this point, engineers will suspect an issue with the third stage design and decide to scrap plans for an AJ-10 third stage in favor of solid rocket motors for their reliability. Each of these iterations will seek to improve one or more aspects between launches, while allowing engineers to familiarize themselves with the tooling of the tanks and other systems. While a failure, this launch would provide valuable lessons about stage reliability and the difficulty of creating the control systems behind the booster. Meanwhile, Gwen, our newest test pilot, has finished up her training on the rocket plane cockpit. The X-3 was attached to the wing of the B-29 and taken up to approximately 8,000 meters altitude before being dropped. Gwen ignited her XLR-25 and began a short climb. This flight would largely be a test of Gwen's ability to handle a ballistic trajectory and guide her plane back in over a long distance. Of course, she continues to prove an excellent pilot, handling lower atmospheric re-entry nicely and bringing the plane onto a nice glide slope. Of course, all of this would have been expected in the application process of joining the ASP. And after a long trip, she would come in, lead energy perfectly, and land at the old Air Force runway and recover her plane. In response to the successful scientific flight of the Ahote 3F, the Florida government commissioned 2 flights of the launcher, the first being on May 14th. With a heading of 40 degrees west of due north, the Ahote booster was sent over central Florida to take pictures of the Ocala National Forest, as a wildfire had sprung out there earlier this spring. The Florida government wanted to track the progress of the burn in order to coordinate relief efforts and direct firefighters accordingly. In this, they demonstrated a use of photography that would improve the safety and reliability of natural disaster response teams moving forward. After some delay due to the upper stage redesign, the Ahote 300 would be rolled out onto the pad on the 1st of July. Crew members would eagerly rush back to the mission control to watch the launch. In theory, the Ahote 300 had the power to make it to orbit, the first craft in ASP and world history to have this capability. However, for this to happen, everything would need to go perfectly, and engineers were not optimistic. Upon main engine cutoff, MECO, the first stage would deploy and drop away, and the fairings would deploy, revealing the newly upgraded second stage. It would utilize a solid fuel kick motor in order to push the small probe into orbit. However, we would still utilize the AJ-10 powered second stage. After the completion of the AJ-10's burn, the third stage would spin up utilizing small solid rocket motors and launch off at the horizon, having received its final guidance from the onboard computer in the second stage. From this point, the final two unguided stages would attempt to push us into orbit. Unfortunately, we would only make it around 8,000 kilometers downrange, and the engineers would prepare a follow-up mission to retest their hardware, determining the AJ-10's burn must have been to blame for the failure. Of course, throughout the entire mission, the probe would continue to transmit science and collect it, sending it to the nearest tracking station available before descending back into the atmosphere. The engineers at the Ahote Light Launch Complex worked tirelessly between their commissioned missions to ready the flight of the Ahote 2, and on July 9th, she would finally roll out and fly. Performing perfectly throughout the ascent, the Ahote 2 would deploy its precious payload into space before recovering it shortly thereafter. This mission was designed to replace the failed one from the beginning of the year, and it would test life support systems in the environment of space, following the incidents on previous Ahote 2 launches. On August 21st of 1956, the Ahote 3F, Flight F, would be commissioned by the Florida government, and the Ahote would turn once again 40 degrees west of due north, traveling over Ocala Forest once more. The focus of this mission could largely be twofold. First, it wanted to collect photographs of the scarring caused by the wildfire earlier this year and showcase the success of the firefighting missions that were aided by the previous Ahote 3F launch. And two, it could also prove as a tourism boost to Florida, showcasing itself as one of the most forward-thinking states in the United States, allowing for rocket launches to aid in its disaster relief. Of course, pictures from this mission would come back and would be recovered in southern Georgia. These images would be published in nationwide newspapers, increasing the fame and the intrigue surrounding the ASP. as well as boost the fame and importance of Florida in the national perspective. Of course, after the increased prestige of the last mission, engineers wanted a break. However, time waits for nobody, and less than 1 week later, the Ohote 300 would be readied for its second test flight. Lifting off the pad, the Ohote 300 would clear the tower easily and began pitching over to the right. This time, throughout the flight, engineers were able to determine that the craft had performed nominally. The AJ-10 was burning well within expected parameters, and the solid rocket motors were spinning the craft up to the correct speed and holding its pitch and heading. Things were not adding up, and the engineers went back to the drawing board. Eventually, over the course of this flight, it would be determined that the expected 9,000 meters per second of delta V that was planned for this mission would not be enough. Engineers expected to need at least 400 more meters per second if they wanted to beat the drag and gravity losses of the Ohote 300 craft. Of course, the scientific data collected by the probe core, designed to reach orbit, performed excellently and admirably, always returning science and sending to the nearest tracking station once available, making this mission something of a partial success. After Gwen's flight in the X-3, the plane would be refurbished and readied for launch. This time, Ernest would be attempting to crest 70 kilometers in altitude, higher than any human had ever been before. The X-3 was prepared utilizing the knowledge gained from the July flight of the Ohote 2, allowing for proper cabin pressure and oxygen levels to be maintained at higher altitudes than anyone had since visited. Unfortunately, the plane would cap out at around 58 kilometers in altitude. Ernest would attempt to utilize the reaction control thrusters to attempt to keep the nose up and gain altitude, but the lift was not there and the plane began to re-enter. During re-entry, the plane would approach Mach 3.4 before rapidly decelerating as it hit the thicker parts of the atmosphere. After this, it would come in high above the Space Center and prepare for a landing, ending the first attempt at a 70-kilometer altitude test. Of course, with the wilder side properly kicked out of Ernest through the procedure updates, Ernest came in for a perfect textbook landing, and the plane would gently come to a rest on the runway. Following this flight, the engineers went to work fast and prepared an upgrade to the X-3, coming up with the X-3 DT, having fitted 2 large drop tanks to the body underneath the wings. The weight would be counteracted by the extra fuel that allowed the plane to reach much higher speeds on its ascent. This allowed for a steeper climb angle and greater lift. This time, Gwen would pilot the X-3 DT, just up to 65 kilometers, just short of the 70-kilometer goal, before her plane started diving back towards the surface of the Earth. Meanwhile, she would reach an unprecedented speed of Mach 4.3 before decelerating rapidly in her dive. An anomaly in the aft of the plane, likely caused by friction from the speed this low in the atmosphere, led to a catastrophic loss of the air brakes in the XLR-25 engine. Now unable to easily slow herself down, Gwen would cautiously pull out of her dive, being careful not to exceed the rated 5 Gs of tolerance on the X-3's airframe. Of course, having hired an excellent test pilot, Gwen would safely return the plane to the runway for analysis, having utilized the emergency parachute system to arrest her momentum. On October 18th, the Ahote 400 would be rolled out onto the pad, prepared to launch, but then scrubbed after a failure of the XLR-43 engine. Engineers would scramble to diagnose the issue, and the flight was rescheduled as the rocket was rolled back for further modifications. While the Ahote 400 team was hard at work, another Ahote 2 was prepared at the Light Complex. It would be launched on October 23rd of 1956, and the Light Complex team was expecting another success. This flight would be yet another test of life support systems, learning from Gwen's record-breaking flight and testing high G loads on pumps, fans, and other critical equipment for manned spaceflight as we inch ever closer to the edge of space in each X-plane mission. Of course, all creatures on board and the materials tests returned safely under parachute to the surface. On October 28, 1956, the reschedule of the Ahote 400's maiden flight would take place. All the issues of the engine had been worked out and they would go for launch. Learning from the Ahote 300, in this flight, engineers made some modifications. They knew that they would need to squeeze as much delta V out of their current design as possible, since they were utilizing the best engines off the test stand, and so they couldn't count on new propulsion tech to help anytime soon. Knowing this, they looked to the structure. Cutting wing and increasing tank size, engineers developed a new aluminum stringer tank that would effectively add 500 meters per second of delta V to the current design and put it into orbit. At Miko, the AJ-10 fired upon fairing separation, but something was wrong. The craft slowly and gently began to pitch upwards. By the time ground control realized the error, it was too late, and the craft had almost lost 300 meters per second in cosine losses. Unfortunately, the error was traced back to a flight controller, failing to arm the reaction control systems before fairing deployment. The worker would be sternly reprimanded, but the damage had already been done, and so he would keep his job, as the rocket would prove an excellent test bed for a downrange record. Of course, the rest of the craft would perform perfectly, and it would ultimately achieve 20,000 kilometers of downrange, nearly halfway across the Earth, before returning to the surface in a ball of fire. Though nearly achieving orbit isn't quite as dazzling as being first to orbit, the planners still considered this mission to be a success. It achieved a major record in downrange distance from the launch site and provided a formidable test of the final launch vehicle that would take the country to space. On November 29, 1956, after a new engine was mounted and new drop tanks fixed, the X-3DT would take to the skies once again. This time, Stacy Wood made an attempt at reaching the 70-kilometer altitude record. He would attempt to utilize new techniques in pitching as instructed by ASP administrators. However, unfortunately, this flight wouldn't even crest 63 kilometers in altitude before dipping down towards the surface. This time, on the dive down, Stacy was wary of pushing out the air brakes until below Mach 3, learning from Gwen's near disaster on her last attempt at the altitude record. Instead, Stacy would utilize a technique he had used many times before, an S-turn. This helped him bleed speed while staying below the G limits of the X-3 airframe, and it didn't expose the air brakes to as much friction. Of course, on a successful deceleration, Stacy would glide the plane in for a clean landing at the long runway. Many engineers felt that they had reached the limits of the X-3 airframe, and a redesign would be needed before they could reach the 70 kilometers of altitude. Unfortunately, many thought this would be the last flight of the X-3. Once recovered, upon reading the flight data of Stacy's flight, engineers were certain the plane would need modifications to reach that height that they wanted. However, Gwen had an idea. She lobbied ASP administrators for days, but they finally agreed to allow a final flight of the current X-3DT. Gwen's plan was counterintuitive, but utilized a technique she learned about flying airplanes at home. She would dive to gain speed, then pull up and utilize her speed plus engine power to climb faster than you could on a normal climb rate. This allowed her to gain unprecedented speed in the lower atmosphere. Then once above the thickest portion of the atmosphere, she engaged RCS and pitched straight upwards, ignoring the recommended pitch rate of 15 degrees. Gwen rightly deduced that the most important part of the flight was leaving the lower atmosphere as fast as possible, and when she reached the upper atmosphere, air behaved differently, something she noticed on her last flight. She believed the plane behaved more like a rocket than an aircraft. It didn't need to adhere to the normal rules of pitch, angle, or lift ratio. This thinking allowed her to crest 72 kilometers, making a new global record for human flight. And upon re-entry, she belly flopped the plane through the atmosphere, allowing it to never breach Mach 4 and thus protecting the sensitive air brakes from a violent re-entry event. Now heralded as one of the greatest test pilots of the ASP, Gwen brought the plane back in for a safe landing as scientists could read through the flight data. Upon the success of the flight, the engineers would read through the data, and they determined that even though the flight was a success, in order to breach a higher altitude than Gwen's flight, the airframe would need some modifications. Thus, this would be the last flight of the X-3 for the foreseeable future. The final days of the year, the last attempt at orbit would be held. Winter began to arrive in Florida, and the Ajote 400 would launch on an especially chilly day, nearly 60 degrees Fahrenheit. Of course, this was planned for, and the rocket launched successfully, clearing the tower and climbing towards space. Minor modifications were made between launches, mostly to procedure more than anything, and as the Ajote booster climbed higher, the mission commander made a final check to ensure the RCS was armed and ready. Thankful that it was, the mission control room fell silent as they watched the rocket shrink into the sky. Cresting the horizon of the nearest tracking station, the probe sent back its telemetry. Orbit was achieved. 879 kilometers by 175 kilometers in altitude. The room would erupt into cheers, and the probe was christened Taeyan-1, the new moon. So how about that launch, everybody? I think that this was quite the successful year. And here, as we watch the Taeyan slowly orbit the Earth, I feel pretty proud of myself. I've never quite done this challenge before with the American-only launch parts, the American-only engines, or not even just American-only, but let's say the non-Russian engines. I've never done that challenge before, and I'm pretty proud of myself. I feel like this is quite the accomplishment. Orbit in 1956. Of course, next year is going to be even busier. Hopefully we'll launch 4 new satellites into orbit. We have to complete our program before the end of 1957, of course. And I'm feeling pretty optimistic. I have a nice schedule here laid out on my screen. Of course, you can't see that, but I'm looking at the schedule. I think we can do it. Obviously, we're going to have to meet some tight deadlines to be able to get these rockets off, but the Ahoti 400 is a well-capable launch vehicle, and I feel like it's proved itself in this episode. Of course, we're going to have the Ahoti 500 next episode, utilizing an actual AJ-10 engine. We're going to start to improve the capabilities of that second stage. That way we don't have to rely so much on the solid rocket motors of the third and fourth stage. But yeah, going forward, I think I'm pretty optimistic about the way this program is headed. Obviously, this is a major milestone, and I think that for all of y'all to continue to watch this series, it makes me pretty happy just to see how far I've come, and I think that this could be considered a new beginning for the program. Obviously, we spend a lot of time working on suborbital craft, but I think largely what you want to do in Kerbal Space Program, especially Realism Overhaul and RP-1, is go to space, do these missions that essentially equal an alternate reality, an alternate future for the United States space program, or the Russian space program, or Chinese space program, whatever you feel is most important to y'all. But yeah, so I'm pretty excited. I'm optimistic to see where the program goes. I'm optimistic that we'll actually be able to complete light satellites next year on a really fast schedule. Only 1 year to complete 4 more orbits. I'm optimistic, but yeah, if any of you like this video, you can go ahead and hit the like button. And if you like my channel, like what I'm doing, go ahead and hit the subscribe button. And leave a comment below if you enjoyed what you saw, or if you had any other questions. And I'll see y'all in the next video.